Hello everyone, I'm Jiajie Chen from Tsinghua University team, and I'm going to give a lightning talk to you. First, let me introduce our team members. Our female team leader, Chen Zhang, responsible for HPCG, CESM, and mystery application. Jiajie Chen for LINPACK, reproducibility, and cloud management. Yutian Wang for IO500, Gromacs, and poster. Zheyu Song for IO500, Gromacs, and cloud management. Mingshu Zhai for HPCG, CESM, and poster. Runxin Zhong for LINPACK, reproducibility, and mystery application. Our mentors include Professor Jidong Zhai, Dr. Wen Taohan, and Dr. Lin Gan. We also have junior backups working in all aspects. Our team has diversity in many aspects, like we have a female team leader, Chen Zhang. We come from different provinces in China, speaking different dialects of Mandarin and Cantonese. Our team consists of experienced members who have won many awards in previous supercomputing contests, and new members from our backup team. We each have different personal interests in courses, academic fields, social works, extracurricular activities, and future plans. We always welcome females, sophomores, and interdisciplinary students. The people from left to right in the picture are Zeyu Song, Mingshu Zhai, Runxin Zhong, Yutian Wang, Chen Zhang, and Chen Jiajie. Next, let me introduce our school. Tsinghua University is located in Beijing, China, and it has a long history. It is without doubt the top one university in China. You can see a landmark of our university on the right of the slide. Then let's go over our software stack. We plan to use CycleCloud 1 to 18 with Azure-tuned kernel so that we can use Hyper-V NVMe direct technology. We use NFS to share files between virtual machines so that we can set up environment once and use them everywhere by mounting the same NFS volume in all machines. We use Spec to manage compilers and libraries, for example, GCC, ICC, Clang, CUDA, cuDNN, BLAS, and MPI. Datasets are also stored in the NFS. We also deployed our budget monitor so that we can adjust our strategy to budget usage in the progress. This year, the competition is held online, so there is a lot to learn to run applications on cloud. We carefully evaluated SKU series and matched them to our needs in each application. We mainly focus on this SKU series. F series for general compute-intensive applications with lower costs, HB series for applications requiring many AMD cores in one node, Azure C and Azure series for applications that can benefit from high-frequency Intel CPU cores, NC and NV series for GPU applications of course, and LSV2 series for I/O-intensive tasks, mainly IO500 benchmark. We use CycleCloud CLI to access clusters and use Spec to manage environments of virtual machines. For preparation, we evaluated SKU by performance and price, trying to balance performance and budget. In the training period, we ran applications with provided datasets so that we can get preliminary results before the competition starts. We try to get familiar with CycleCloud environment and set up Spec and NFS environment. This is our first time to use CycleCloud, and we learned a lot about what HPC is like in public cloud. This should be quite useful when the competition begins. Here is our optimizing strategies for applications. Generally, we investigate in 4 ways: profiling, code improving, architectural improvements, and compiler and parameter tuning. We use profiling tools from CPU and GPU vendors to find out the hotspots and try to optimize them by rewriting the code. Leveraging our knowledge in computer architecture, we can improve cache locality, reduce alignment issues, and more. We will tune some general parameters like MPI settings, CPU affinity, and UMA binding, and some specific parameters of each application. Now, let's go over the specific optimizations for each application. As the application name suggests, it focuses on matrix computation and solving. For LINPACK and HPCG, we will tune the parameters, test different GPU cards, and use as many GPU nodes as possible. So we will use NC series virtual machine because they have high performance GPU cards, and use promotion ones when available. Because the benchmarks have predictable score, budget, and runtime based on our prior knowledge, we will begin late in the competition after we can predict the budget of other applications. Next one is I/O 500 benchmark. It measures the idle bandwidth and operations per second of a storage system. We wrote a custom file system called MetFS for I/O 500 benchmark, and we'll use nodes of LSV2 series with NVMe storage to run it. Besides, communication between nodes can be very important, so we can use machines with InfiniBand. The reproducibility challenge this year is MemXC, an X-ray CT reconstruction tool. With comprehensive understanding of the MemXC paper, we plan to do experiments under different architectures and data to reproduce the results. We will test different parameters, do scalability tests, and visualize them according to the original paper. We plan to use F-series to run CPU workloads and NC-series for GPU. Because the original paper uses different GPU cards like K80, P100, and V100, we need to use the same cards as well. If budget is enough, we also want to try AMD machines. We tend to evaluate the performance first because the tests are already known and more time is left for report writing. Gromacs is a versatile package to perform biochemical simulation, and we want to understand the biological interaction behind it. Specifically, we will tune performance by domain composition, changing PME settings, improving GPU communication, thread partition, and experiments on different SKU settings. We choose to run Gromacs on GPU machines with all tasks starting at the beginning of the competition. Thus, NC or ND series should be used for this application. CESM models the climate system of the Earth, and we will try different combinations of compilers and MPI libraries and use parallel net CDF library to improve I/O performance and tune settings for better load balancing. We will do some initial experiments for CESM to find the best mapping between processes and components, and allocate remaining budget to it when other tasks are finished. We plan to use HC series or HB series because it can leverage the large number of cores in an instance. For mysterious application, we first try different compilation methods, then schedule the budget according to the situation of other applications, and then analyze according to scalability, communication intensity, and GPU friendliness. We have no knowledge of mystery application yet, so we will need some time to read the code and document before we can work on it. We don't know whether the application is CPU or GPU intensive yet, so we will accommodate our SKU choice when mystery application is released. We have written an Azure Budget Monitor that collects the budget usage over time. Then we can visualize the budget usage data in Grafana and set up alarm to avoid budget overuse. When budget usage goes across a threshold, an alarm will be sent to our Slack channel. This year, the competition is held online, and we have to use an online cluster to run the applications. The budget, and quota are limited, so managing cloud resources and balancing budget and performance are the great challenge to us. Because the servers are far from us, we have a large access latency, and the communications on the mailing list have a long round-trip time because of different time zones. The best thing we could do is to prepare ourselves and get used to the new setting. And our ultimate way to overcome this is teamwork. We are all at school campus now, so we can get together locally at school. We can communicate with each other freely, face to face, and tackle with challenges together. So we can have weekly meetings with graduated team members to learn from them. That's all. Thank you, everyone.